welcome to this explainer. Today, we're diving straight into an event that literally altered the course of human history, the anatomy of the Chernobyl disaster. We're going to break down the exact science and the precise sequence of failures that happened on April 26, 1986. Let's get right into it. So how exactly did a routine safety test trigger the world's worst nuclear disaster? I know, it sounds totally contradictory. The whole point of the test was actually to make the plant safer. They wanted to know if the power went out, could the spinning turbine still generate just enough juice to keep the cooling pumps running until the backup generators kicked in. But to pull this off on the Soviet RBM K1000 reactor, the operators had to push the system into a really unstable state. And this brings us to a ticking clock scenario. Believe it or not, basic administrative delays set the whole tragedy in motion. This test was originally supposed to happen during the day, with a crew that was fully prepped. But the Kiev energy grid needed power, so they delayed the test for hours. Because of that, this highly dangerous procedure was just handed off to the night shift. These guys were way less experienced and completely unprepared for what was coming. By the time the clock hit 1:23 a.m., the countdown to disaster had officially begun. Almost immediately, the crew hit their first massive hurdle, xenon-135 poisoning. To do the test, they had to drop the reactor's power. But thanks to an operator error, the power plummeted way too far, dropping from around 700 megawatts all the way down to a measly 30 megawatts. At this near-zero state, a byproduct gas called xenon-135 started building up incredibly fast in the core. It absorbs neutrons, so it essentially chokes the nuclear reaction. To fight this choking effect and force the power back up, the operators had to push the system really hard. Which leads us to a fatal chain of errors. First, with the power sitting up dangerously low, the reactor was already critically unstable. Second, to overcome that xenon gas we just talked about, the operators pulled almost all of the control rods out of the core, going way below the absolute minimum safety limits. And finally, just to make sure the test wouldn't be automatically interrupted, they actually disabled the automatic shutdown and emergency cooling systems. They completely stripped the reactor of its defenses. The operators were essentially flying blind, looking at control panels that just did not reflect the catastrophic danger building inside the core. Now, to understand what happens next, we need to look at a fatal design flaw unique to this specific reactor. It's called the positive void coefficient. When the operators started the test, they shut off the steam valves, which meant the flow of cooling water decreased. As water decreases in this reactor, it boils into steam bubbles, or voids. Now, in most modern reactors, losing water slows the whole nuclear reaction down. But here, the steam actually increases reactivity. So as those steam bubbles built up, the reactor's power just started climbing, totally out of control. Okay, so the power is surging. Alarms are almost certainly blaring in the room, or at least in the minds of the operators. It's 1:23:40 a.m. Realizing they're in extreme danger, an operator absolutely slams the AZ5 emergency button. This is the ultimate kill switch. Hitting this button is supposed to instantly drop every single control rod back down into the core to completely kill the nuclear reaction. It was supposed to be their salvation. But here's where the tragedy turns into an absolute nightmare. Those control rods, the ones meant to absorb neutrons and stop the reaction, they had tips made of graphite, and graphite actually accelerates reactivity. Since it takes about 18 to 20 seconds for the rods to fully insert, those graphite tips entered the core first. So instead of acting as a brake, the kill switch literally acted as an accelerator. For those first few agonizing seconds, pressing stop actually caused the reaction to spike massively. In just a matter of seconds, the power level inside that reactor skyrocketed to roughly 100 times its normal operating capacity. Let that sink in, 100 times. The heat got so intensely hot that the nuclear fuel rods themselves literally shattered. All the remaining cooling water instantly flashed into a massive amount of steam, creating just an unimaginable amount of pressure inside the vessel. And all that immense steam pressure had to go somewhere. The result was a catastrophic explosion that blew the 1,000-ton lid right off the top of the reactor. Just imagine the sheer force it takes to launch 1,000 tons of metal and concrete up into the air. That was quickly followed by a second explosion, likely from ignited hydrogen. The building was completely torn apart, leaving the burning, highly radioactive graphite core totally exposed to the open night sky. So let's step back for a second. Why did this actually happen? Well, it wasn't just a machine breaking. It was a total systemic failure. On one hand, you have severe design flaws, the positive void coefficient and those incredibly deadly graphite-tipped rods. But on the other hand, you have major human and systemic errors. Operators were severely violating safety procedures because they just lacked the proper training. And hanging over all of this was a Soviet culture of extreme secrecy. The state actually knew about the reactor's flaws, but they hid them from the operators. Without that secrecy, they might never have pushed the reactor to the absolute brink in the first place. Meanwhile, as the reactor burned, a human tragedy was quietly unfolding right next door. The next morning, the city of Pripyat, home to 50,000 people, just went about its normal business. Kids were playing outside, weddings were even happening. Because radiation is an invisible threat, the citizens had absolutely no clue they were breathing in deadly toxins. It took a staggering 36 hours before officials finally ordered an evacuation. People were loaded onto buses and told they'd be back in a few days. Spoiler alert, they never returned. All the while, that exposed reactor was basically vomiting a deadly radioactive cocktail directly into the atmosphere. The graphite moderator burned for days, acting like a giant open chimney. It spewed iodine-131, which is short-lived but poses a severe risk for thyroid cancer, particularly in kids. It released cesium-137, which has a 30-year half-life and drastically contaminates the soil. They also detected strontium-90 and even traces of plutonium. These highly radioactive clouds blew across Belarus, which actually absorbed about 70% of the fallout, and then spread right into Russia and across huge portions of Europe. But wait, back inside the ruins, an even bigger terror was forming. The intense heat caused the nuclear fuel to melt together with concrete and metal, creating this horrific molten lava called corium. It literally began burning right through the floor. The most famous mass of this stuff is known as the elephant's foot, a blob so radioactive that just a few minutes of exposure was completely lethal. But there was a more immediate threat. Pools of water were sitting directly beneath the reactor. If that molten lava hit the water, it would trigger a massive secondary steam explosion, one that could have rendered a giant chunk of Europe totally uninhabitable. Enter 3 heroic volunteer divers. They waded into pitch-black, contaminated water just to open the valves and drain those pools. They risked absolutely everything to prevent a second apocalypse. What followed was an agonizing, massive cleanup effort. Over 600,000 soldiers, engineers, and workers, who became known as the liquidators, were mobilized. The very first responders, the local firefighters, actually showed up in their standard gear, completely unaware they were fighting a nuclear fire. Tragically, many of them died within weeks from severe acute radiation syndrome. The liquidators who came after them flew in helicopters pouring sand, lead, and boron directly into the blazing core to try and smother the fire, often absorbing massive, life-altering doses of radiation themselves. The radiation up on the reactor roof was so intense that when they brought in remote-controlled machines to clear the debris, the robots literally short-circuited and died. So what was the solution? Human beings. They called them biorobots. Soldiers were sent out onto the roof to manually shovel highly radioactive graphite blocks over the edge by hand. Because the radiation was just off the charts, their survival limit for exposure was strictly timed between 40 and 90 seconds. Imagine that. You have a minute and a half to sprint out, shovel a piece of radioactive debris, and sprint back before you absorb a lethal dose. The physical scar this left on the Earth is massive, spanning a 30-kilometer radius. That's the exclusion zone they established around the plant, and it remains largely a restricted area even today. Now, you might have heard about the eerie resurgence of wildlife there, wolves and deer reclaiming the abandoned towns, but the idea that nature has just healed is kind of an illusion. The soil is still deeply contaminated, and the radiation continues to heavily impact the ecosystem there. To try and stop the ongoing leak of radiation, an initial concrete sarcophagus was hastily built right over the ruins in 1986. But over the years, it started degrading. That leads us to an absolute modern marvel of engineering. In 2016, this massive steel structure called the new safe confinement was literally slid over the old sarcophagus. It's basically a gigantic shield designed to contain the lingering radioactive threat for the next 100 years. Essentially, it's buying humanity time to figure out a permanent solution. Ultimately, all of this builds to one really profound conclusion. Chernobyl was a perfect storm. If the design wasn't flawed, the operator errors wouldn't have caused the explosion. If the operators had just followed procedures, the design flaws might never have been triggered. And if the safety culture wasn't completely steeped in state secrecy, neither of those things would have happened. Chernobyl wasn't just a failure of technology. It was a massive failure of the human systems we built to manage it. It forces us to ask a tough question. As our technology grows infinitely more powerful, is our commitment to truth and safety actually keeping pace? Definitely something to think about. I'll catch you in the next explainer.